is Tim Shepard with the Vintage Airstream podcast. I want to do a quick little video on some solar testing. I've been working with Ralph over at Bogart Engineering on his charge controller, the SC2030, and that hooks up to the Trimetric 2030, and they work hand in hand to form a smart solar charger. So I'm going to compare that with the original charger that I have with my Go Power system. I have 400 watt flex Go Power solar panels and the 30 amp PWM charge controller from Go Power as well. I did a test when I first put in the Go Power equipment back in, I guess, June, July, so middle of summer when the sun was pretty much straight ahead above, but now it's winter, it's November, it's approaching winter anyway, and the sun is drastically changing its arc over my coordinates where I live, and so I just want to see how that affects the amount of current capable as well, or the amount of current that's available from the panel. So I'll show you what I've done here so far. Okay, here's a quick close-up look at the equipment. This is the SC2030. It's the charge controller. It can be used standalone, but when it's used with a Trimetric 2030, that's where it really pulls away from the rest. Here's the 2030 RV, a little bit smaller, might look better if you mounted it in your wall. And then the older version being, this is what the Trimetric 2020s look like, which is what I had, which is just the battery monitor. This is still the same exact brains as this one. In fact, this board fits on both panels. It's just on the old plate so that you don't have to do a new cutout, so it'll match your trailer. And that, if you have an old one you just want to replace, then you want to get the TM2030A. Okay, here is the Trimetric TM2030A battery monitor. So what I've been doing all morning is just pulling a lot of current. I have my solar turned off, and I've been pulling about 10 amps. This shows you the amps. Capacity was at 100, it's dropped down to 94, and the battery voltage is 12.3. This meter has a special mode where I can track the charger output, the SC2030, and that's what this is doing. It's not connected right now. So we'll go in the back toward the batteries. Here's the batteries. Well, there's the SC2030. It's disconnected right now. This is the original charger, solar charge controller from Go Power, and it's showing 12.3 volts. So I'm drawing 10 amps because I got my inverter turned on, I got all the lights turned on, I got the fan turned on, just to give a good load. So 94%, 12.3 volts. Okay, so the Trimetric shows the delta, the difference between the outgoing current for the trailer from the batteries and the incoming current from the solar panels. So that's why we're seeing what we were saying. I'm going to do it again. Turn the breaker on. 11.4 amps coming in from the sun. 7.4 on the fluke. And the delta is 1. Okay? 1 amp coming into the battery charger. So now I want to test lowering the tongue of the trailer, because now the sun is toward the front. It's at an angle like this, hitting the flat roof where the solar panels are, which I showed in the picture earlier. First thing I did before I did any of this was wash the panels so they're clean, so I get a good test between now and last July. So since it's later in the season, the sun is actually coming at the trailer at an angle like this, and the panels are flat. So we know we have 11 0.4 amps coming in. I just looked again. I'm going to lower the tongue of the trailer and see if that has any effect. That would effectively point the panels more directly at the sun. Okay. So I lowered the tongue, which wasn't very much actually. But it did increase it. It went from 11.4 to 11.8, 12. So it has an effect. So aiming them more at the sun did make a difference. Okay, so that's the first part of my test. Maximum current in the wintertime, even less really, because I wouldn't park anywhere and tilt my trailer oddly like I have it now. But being that the sun isn't directly overhead, I'm not getting maximum power. That's the whole having panels that you could tilt toward the sun, especially in the wintertime. Mine are flexible panels. They're permanently mounted to the roof, as you saw in the picture earlier. So to aid in that, there are some other things that you could do, I guess, for the wintertime. But anyway, let's go ahead and disconnect all this, and we'll hook up the Bogart Engineering, the SC2030, and we'll get it configured with the trimetric, and we'll see how that compares. Okay, here we are back. Same setup, only the Bogart SC2030 solar charger is connected. We still have our 10 amps that we're drawing. We're down to 92% of battery capacity, and 12.3 volts. Now on the 2030, one of the reasons why I like this configuration is if you push and hold this, you get a second set of items. So that's how many amp hours I'm using. This is day sense charge, day sense equalized, but the real important one I want to see is the solar. Okay, so that's how much solar power is coming in, solar current. So, and before I had to go back and read the second Go Power solar charger to be to see this. Now, with this setup, everything is going to be in this one spot. So we're going to pretty much do the same kind of a deal. Come back and we'll look at the solar controller is now hooked up. You can tell the green light is on. Let me turn off the light here. Okay, so that might help. You can see the green light is on, and that means it's talking to the trimetric meter. Okay, and it also tells you some other things when it flashes. The yellow light is off because I have the solar turned off right now. You can see that I have no solar power coming in. That's the fluke showing us what's going on. So let me go and hit the breaker. And you'll see the light came on. That means there's solar power present. Okay. And here we go. We've got 10, 11 amps coming in. Well, that's good. Very close to the Go Power. If you watch the green light when it's flashing, okay, it flashed once. Gotta watch it when it's on most of the time. It means it has communication. There was a one flash. It means it has communication to the solar controller, or to the trimetric. So here we show we have 10.9 amps coming in. That's what the fluke's showing, 11, okay? So we should be pretty much of a wash because we were drawing 10. So we have 0.9 amps, 0.8 amps going into the batteries. Now that one light flashing on the charger controller means it's in bulk charge. So it's trying to charge the battery up to back to 100%, use as much as it can. So you can read that light back there and you can see if it flashes different rates. For instance, it'll show you if it's discharging, in a float charge, absorb charge, or what have you. Now this meter has a special mode. Usually this will show your battery too, but I have a special one for this testing only, and it shows 263. So I have to look at a chart. The 2 means it's in bulk mode, like I just mentioned, so it's doing as much capacity as it can to the batteries. All solar currents coming into the batteries. And then the 63 is a kind of a technical number. It varies from 00 to 63. 63 meaning the maximum amount of current from the solar is being applied through the solar charger. So right now I'm in bulk mode, getting the maximum charge from the solar panels to the batteries. And to see what that is, again, that's the delta. I have 10 amps going out, close to 10 amps. And then if you cycle through solar, got 10.7 coming in. So that's good. I'm pleased with that. Okay, like I said, this is the current amps on the trimetric. This is the delta, the difference between what's coming out and what's going in. So let me go ahead and turn off some of my loads. I'll turn off the inverter here. You can see that was kind of a big load. Even just being on, it draws like 4 amps. I have a bunch of DC lights on, even though they're LED. They still draw a little bit. See how it went up there? So I'm going to go through, I'm going to turn off all my extra loads that I don't need. We'll see what we get to the batteries. So this is what's getting to the batteries, and if you want to see what's coming in from the solar panels, you push and hold, you see the alternate menu, cycle through to solar. So I have 9.7, 9.8 amps coming in from solar right now. So what it's trying to do is it's trying to bring that battery back up to the full charge. So this is kind of handy because, like I said, you can see it all in one place. So I'm still in bulk mode, passing all power. So bulk mode 2, all power, 63 is coming in. Normally, your meter wouldn't have this. Your meter would show what's on B2. If you want to see this information, you would look at the LED on the SC2030, and that would tell you what mode it's in. And then the other nice thing you can do, so I'm getting 9 amps to charge the batteries. The batteries were at 90. We'll see if it starts coming up. You could push and hold this to the alternate menu. 9.8 amps coming in, and unused power is 0 because I'm using all power from the sun right now to bring these batteries up. What unused power will show you is once these batteries are full and there's no current really needed in the trailer, then it'll show you how many watts are available from the sun that you could use during the day and not affect your battery capacity. So that's what the UPR, unused power, is for. Unfortunately, right now I'm having to use all the solar power right now to charge up my batteries. That's the temperature of the battery. There's a temperature probe that you can get as an option for the SC2030, and I think it'll affect the charging algorithms depending on the temperature of your battery. Mine's at 20 degrees Celsius right now. So it's climbing up, 13 volts. Now if you can see, we're already at 92%. So we're still charging up. So I did talk about the benefits of using the trimetric battery charger system instead of using just the included one from Go Power, or whatever solar you have. This works up to 30 amps. It's a PWM, pulse width modulation charger, and it's good for 30 amps, or probably like close to 500 watts. Probably 400 watts, 450 watts would be about the max. Besides being able to see in one display the amount of solar coming in and the amount of power being used and your battery capacity, which is all very handy. The other benefits of the trimetric system is it knows how much power your battery has in it, because it actually tracks the power coming in and out. It has a battery shunt, which we've talked about before. So it's not just doing it based on voltage. As you can see, the Go Power one, it doesn't have all that information, so it just does battery capacity based on voltage. If the voltage is 12.3, there's like a chart that's on the internet you can look up, then it's going to assume your battery capacity as this specific level. If it's 12.4, then that level. Where the trimetric, it actually knows a lot more because it tracks the power coming in and out of your battery, how much current's coming in and out, how much you're using, how much solar's coming in, and you've told it the battery capacity, and it also tracks the characteristics of the battery. Like when it's charging, it looks for a peak voltage and then a drop off in current, so that it reached a certain charging point, so it can really track better what the real state of your battery is in. And since it can control the solar charger, it knows how much power is coming in, how much current's coming in, and there's a specific amount, because batteries aren't 100% efficient, so there's a specific amount of overcharging. And I don't mean that in a bad way, but you want to put more power into the battery than what you've taken out, and there aren't many, I don't know if hardly any, if any, solar chargers that do that. And so when this controller and charger are working together, it can control that, and you can get the exact right amount of power back into the battery. And then it also has a temperature compensation too. So those are actually the real technical benefits why you'd want to do something like that. And then just the other real one for me too is just being able to see everything in one place. So there you go, the Trimetric 2030A or 2030RV if you want the new modern looking one. They both functionally do the exact same thing. And then the matching charge controller is the SC2030. You can buy just the battery monitor, the TM2030, and use it until you get solar one day, so you'd have it and you'd be ready. Or if you don't have the battery monitor and you have solar, you can just use the SC2030 on its own, but they really work better when they're together. All right. Okay, I hope that helped you out. A few different tests we did was comparing solar power between summer and the fall, with the sun either straight up above or off at an angle. We saw that we were getting about 11.2 amps. Then we aimed the tongue down on the trailer. It really didn't move very much at all, unfortunately, but just because of my driveway and all that. But I did aim it more a little bit, and it brought the current up about a half an amp. So if you could move it more drastically aiming it during the wintertime, you would get more power. One option I mentioned earlier would be to get a portable solar panel, which GoPower sells, and it's in like a suitcase that unfolds. You can aim it, move it around, and you'd plug it into a cable on the outside that's hooked to your batteries, and that would allow you to aim it through the whole season. And then the rest of the time, just keep the ones on the roof. I think for my research, it only really affects it for about 4 months of the year. So like in June, July, so like April, May, June, July, August, you'll get maximum power, probably about 90-something% efficiency. As you get into October, November, it drops to like 60, down to about a little bit less than that, about 50. When you get into December, January, efficiency, this is with, and I'm talking about a flat panel with the sun not being overhead anymore. So your panel is horizontal like that, and the sun has moved, right, because of the season. So instead of the sun coming straight down your panel, it's coming in on the side. So as that happens, that efficiency changes. So in the summertime, when the sun's right above maximum efficiency, about 90-something% on your panels, as it comes down, like I'm in November now, I'm getting over 50%, 56, something like that percent. And that showed with the numbers, because I was getting about 20 amps in the summertime, and excuse me, now I was getting about 11.5, 12. So it actually, the math actually works. So December it'll be a little less. It'll be in about 45%. Same with January. And then February, March, it starts coming back up. And I think about April or so, you're back into the high 80%, 90s, and then you're good again until the fall. So it's really just a 4.5 month period where you really get affected. That's why you might want to overbuild your panels a bit, because I could still get 10 amps even in the wintertime so far. And so that's fine. So that's kind of why it's overbuilt. And in the summertime, I'm 20 amps, no problem. So that was one test we did, fall versus summer, angle of the sun. The other test we did was comparing the GoPower included solar controller. They're both PWM, pulse width modulation controllers. We compared both of them, and I'm satisfied. I'm couple tenths of an amp difference isn't nothing to me. So with the benefit of being able to read the solar coming in all in one place, it's very nice. So the two controllers worked equally well, and I think that's about it. They worked like I expected, so or hoped, anyways. So hope you gained something from this. I'm sure I did, and we'll catch you down the road next time. Thanks.